Everything you needed to ace science in one big pad notebook. Science. Chapter 6. Matter, properties and phases. Matter and atoms. Matter describes everything that we can see, touch, smell, or feel. In other words, matter is anything that has mass and take up space, including air and almost everything else. Matter, anything that has mass and take up space. Atom, the smallest unit of matter. The smallest unit of matter is called an atom. If you chop a piece of metal into a bajillion pieces, the smallest bit you are left with that still has the properties of the metal is called an atom. A word atom is derived from a Greek word that means cannot be divided, and the Greeks didn't even have a particle accelerator. Atomic models. Remember that a model is a way to represent something that we can't easily see. Atoms are made of smaller particles. Protons, positively charged particles. Neutrons, electrically neutral particles, which means they have no charge. Electrons, negatively charged particles with almost no mass. Electrons, protons, neutrons, nucleus. Nucleus, the center of an atom formed by proton and neutrons. Proton and neutrons stick together to form the center of atom called nucleus, which has a net positive charge. Electrons orbit and circle around the nucleus, but too quickly to pinpoint their exact location. The modern atomic model shows electron cloud rather than individual electrons like the model above. It demonstrates where you are most likely to find orbiting electron. Dense area of the cloud mean a higher probability of electrons. Brief history of the atomic models. John Dalton was the first scientist to propose the elements are composed of indestructible atoms. He saw that there were particles so small that we could not see them. He called these particles atoms, and his theory on matter was known as the atomic theory of metals. So Joseph Jones Thomson discovered the presence of negatively charged particles, electrons, in atoms and pictured them embedded in positively charged particles, kind of like raisins in oatmeal raisin cookies. Ernst Rutherford worked out which atom has a small and heavily positively charged center, which is called a nucleus. Mostly empty device, empty space. He called the positive particles in the nucleus protons. Rutherford's students, James Chadwick, proposed the existence of uncharged particle in the nucleus, which he called neutrons. Physical and chemical properties and changes. The way something looks, feels, smells, and tastes are all physical properties. It's easy to classify matter by these characteristics. Some common physical properties used to differentiate matter are color, size, density, and malleability. How easily something can be flattened, stretched, or pressed. Magnetism. Whether one or something is magnetic. Boiling point and melting point, the temperature at which something boils and melts. Solubility, how easily something dissolves in another substance. A physical change is any change of physical properties of matter such as its size, shape, and state, solid, liquid, and gas, vapor. The final product of any physical change is still composed of the same matter. For example, you can revert ice, snow, or vapor back to water by either heating or cooling it. Ice, vapor, and water are all the same matter, just in different states. Chemical properties describe the ability of something to undergo different chemical changes. Some examples of chemical properties. Flammability, how easily something lights on fire. Reactivity, how reactive something is to oxygen, water, light, etc. When any of these chemical properties change, the matter has gone through a chemical change, rust on an iron gate, or or a log burning and producing ashes are both examples of chemical changes. Some signs of chemical change may be included chemical change and metal change into new substance into new properties. Change in color. This is like when you leave a sliced apple out and it turns brown. Change in energy. The chemical react releasing energy in the form of bright light and heat. Think of fireworks. Change in odor. Think of food going to rotten. Formation of gas or solid. When you add two substances together, such as vinegar and baking soda, you frequently see bubbles. Bubbles or gas formation are a sign that the ingredients have undergone a chemical change. Chemical changes are often much harder to reverse than physical ones. Just imagine trying to turn ashes back into a log of wood. Synthetic materials are materials that don't occur in nature but are instead made from natural resources that undergo a chemical change. For example, polyester is a synthetic fiber made from air, water, coal, and petroleum. Acid and alcohol are used to create a chemical reaction which results in polyester fibers. Conservation of mass. While things may change appearance and composition during physical and chemical changes, one thing remains consistent: the amount of matter present. The concept is called the conservation of mass. Conservation of mass, the amount of mass at the start of a reaction will equal the amount of mass after the reaction. So, mass doesn't just disappear, it still exists, but it may be in a different form, like in the surrounding gases. The atoms have just rearranged to form different substances. Reactants. Substance is changed in a physical or chemical reaction. Product. The resulting substance of a physical or chemical reaction. The reactant is equal in mass to product. Reactant, product. States of metals. Metal is usually found in three states: phase, solid, liquid, and vapor or gas. The arrangement and behavior of particles is what determines the state of metal. The attraction between particles keeps particles close together, and the energy of their movement allows particles to overcome these attractive forces. Solid, like ice, wood, or metal, is a metal that has a dependent shape and volume. The particles in metal are packed closer together and they don't move around freely, which is why a solid has a definite shape and volume. Still, particles in a solid vibrate back and forth, but not enough to overcome the attractive force between particles. Liquids are free-flowing and assume the shape of the container and hold them. Liquid, however, to have a fixed volume, particles in liquid move around fast enough to overcome attractive forces. While the liquid particles to move freely, they still stick together. The speed at which a liquid flows depends on its viscosity. Viscosity is the resistance to flow. Vapors or gases don't have fixed volume or shape. The shape and volume of a gas depends on its container, and unlike liquid, it will fill any container you place it in. The molecules in gases spread easily far apart and move at high speed. Gas molecules move so quickly that they are able to overcome attractive forces between particles, which allows the molecule to separate on their own. If you spill the gas from a balloon onto the air, it will disperse evenly into the air. State features movement of particles. Solid, fixed shape and form. Vibrate but have fixed position. Liquid, shape can change, volume is fixed, can flow. Free moving, no fixed positions. Gas, shape and volume not fixed and depends on container, can flow. Particles move quickly and are far apart. Phase changes. A state is not permanent. Changes in pressure and temperature alter metal. These are described as phase changes. Melting is when metal changes from solid to liquid. The melting point is the temperature at which a solid melts. Heat causes solid to melt by increasing the movement of particles. As the particles gain more and more energy from the heat, they move more and more until they are no longer fixed in place. Above 100 degrees Celsius, water is a vapor. Between 0 and 100 degrees Celsius, water is a liquid. Below 0 degrees Celsius, water is a solid. Freezing is when metal changes from liquid to solid. As liquid cools down, the particles move less and less. At some point, the motion of particles can't overcome the attractive forces between particles, and the liquid turns to solid. The temperature at which a liquid freezes is called the freezing point. Evaporation is when liquid turns to vapor. When sweat disappears and dries up, it has vaporized and evaporated. Evaporation happens slowly only at the surface. Individual molecules get bumped out into the air. When water boils, it has reached the temperature at which water turns from liquid to vapor. It causes liquid particles to move around quickly. When the particles are moving around fast enough to overcome all attractive forces between particles, the liquid turns to vapor. Condensation is when vapor turns to liquid and you get a really cold drink. The air around the glass condenses and forms little water droplets on the surface of the glass. When water vapor in the air cools down, loses inner energy, the particles start to slow down. And the particles slow down enough, the attractive forces between particles cause the molecule in the vapor to stick together, forming a liquid. Sometimes, under the extreme condition, solid can change directly to vapor, which is called sublimation. Dry ice, for example, sublimated when the short ice turns directly into short vapor. Vapor sometimes change directly into solid, which is called deposition, like when frost appears on glass overnight.